Hello student, welcome to lesson 3 of module 1 of this online course on college algebra. In this module, we are studying functions and linear functions and equations and inequalities involving them. In the first lesson, we had an introduction to the number systems and the coordinate system, which we need to study the functions and to graph the functions. In the second lesson, we had an introduction to the concept of relations and function. When does a relation become a function? And the concept of domain and range of a function, and so on. And in this lesson now, we'll start with studying functions themselves, and we study the simplest of them, the linear functions, in this lesson. Okay. So first, some basics. A linear function is, as the name suggests, given by a linear expression ax plus b. Okay. The important thing here is the degree of x, degree of the variable, okay, which is x here, is 1. That is important. Okay, so it is linear. If it is x square, you cannot call it linear. If it is under root x, you cannot call it linear, right? Ax plus b, and a and b must be constants again. See, if you say it is a function of x, only that x can vary, right? Other things has to be constant. So a and b are constants here. That is, they are fixed real numbers. Okay. So here is an example. F of x equals 3x plus 4. And when we write functions, often we write like this. Okay. Y equals f of x equals that. So these are notations. Writing like this f of x indicates that it is a function of x. X is the independent variable. F, the function depends on x. And because when we graph the x, the input is on the horizontal axis and the output, the values of the function are on the vertical axis, right? We also use y to denote that f of x. Okay, so y equals f of x equals 3x plus 4. Now, whether we write explicitly like this or not, it is always understood. Okay, the values of the functions are the y values and the values of the independent variable are the x values. Inputs are the x values. Now, coming to the linear function, f of x equals ax plus b. The a and b have specific meanings. Okay, you can see that a is the coefficient of x, b is the constant term in the function, right? Standalone, a separate constant term. So what are the interpretations? The interpretation is a represents the rate of change. Okay, and I'll tell you in what sense. See, if you plug in x equal to 1 here, let's evaluate this. Okay, f of 1 is 3 plus, or let me do f of 0 first. F of 0 will be 0 plus 4, 4, and f of 1 is 3 times 1 plus 4, so 3 plus 4, which is 7, right? So what is the role of this 3? The difference between 4 and 7 is 3. So when there is a unit change in the input, when the input changed from 0 to 1, the output changed from 4 to 7. The amount of change in the output is 3 when the amount of change in the input is 1. That 3 is to 1 in the rate. okay, the rate in which the output is changing. So that is the interpretation of A. And what is the interpretation of B? The answer to the question interpretation of B lies here. F of 0 equals 4. So if this was some, one interpretation, if this was some, let's say, time related real world situation, if X represented time, then F of 0 will be when X is 0, that is the initial value. So at the beginning, what was the value of the function? Where did we start with? For example, in a real world, you might be wanting to, let's say, save money for a vacation, and you plan to you open an account for that, and you are planning to set aside some money every month. But when you open the account, you might want to put in some deposit, right? Let's say your target is to have $10,000 saved for your vacation, but you put in $2,000 right at the beginning when you open the account, and then every month you put in, let's say, $200, $300, like that. So that initial amount that you had would be like your B here, okay, when the value of X is 0. Okay, so the interpretation of B is initial value of the function. Now that word initial you have to understand in quote unquote, okay, and then that meaning of the word initial can be according to the real world context. Okay, or F of 0 is B. Now this is a linear function. There is another reason we call it linear function. Okay, linear comes from line, right? So the graph of a linear function is, of course, a straight line. So if you take x-axis and y-axis and you plot all the values, when you try to join them, you'll get a straight line. Okay. Now we will be doing examples. Don't worry, very soon. Okay. 3 cases of straight line. Now the graph is a straight line, and if you look at straight line, there are 3 cases, and based on what 3 cases, in terms of what, visually, when you look at it, you have the coordinate system, you have the graph, and you look at it visually in terms of the slope of the line, which brings me to this again. This rate of change that I was saying earlier is also the slope of the line. Okay, so in terms of that slope, there are 3 cases of a straight line. What are they? Horizontal line. So let's say this is your coordinate system, and you just have a horizontal line like that. And in terms of the slope, that is when the slope is 0, the A value in that AX plus B, that A is 0. Okay. Why is the slope 0? It's good to understand that also. It's a horizontal line, right? Remember, we said the value of the function is on y. The y value on the graph is the value of the function. Now, if you look at any 2 points on this function, the y value does not change, right? It's going to be the same. Let's say this is x1, that is x2. So the first point here is x1 comma y. The second point is x2 comma y. It's on the same height from the x-axis. There is no change in y. The rate of change is 0. The slope is 0. Okay. Then the other case is vertical line. Like that. Okay. And now in a vertical line, just the opposite happens in terms of the slope, right? Now, for the same x value, call it x, you can have two different y values, This is x, y1, and that is x, y2. So the values change from y1 to y2 without any change in x. Okay. So in terms of this concept of slope, the formula we are going to see shortly, in terms of concept of slope, you see that there is no way you can define the slope. There is no change in x. So what rate? There is, the y is changing randomly basically. And y can take any value without x ever changing. So we say in this case, slope undefined. Okay, that is another case of a straight line, vertical line. In general, now these are two extreme cases, right? Slope is zero, horizontal line. Slope is undefined, vertical line. Now this meaning of this word in undefined is also sometimes taken as plus minus infinity. Okay, the formula later will make it more clearer. When I say undefined, it's not a finite number. Okay, it's infinite. These are two extreme cases, slope zero and slope infinity. When it is anything in between, that is the oblique line. Okay, so the oblique line is when 0 is less than that slope is less than infinity, or it could be negative also. Okay, negative infinity is less than a less than 0. So basically between one of the infinities and 0, some finite value, you know. Uh, so this whole thing is to simply say basically finite. Okay, finite. That is when you have an oblique line. So as an example, we will look at this function y equals 3x plus 4. It's an oblique line. And I'm going to sketch a graph of that function now. And the technique that I'm going to use here is something you want to pay very close attention to. Okay, the graph of that slope line. And I'm going to use the interpretation of A and B that we talked about a second ago to graph this function. Okay. What is the two things here? The initial value, y of 0. Okay, we can also write like this. Y is a function of x here, So y of 0, when x is 0, the value of y is 4. And the slope of this line is 3. Right? We have those two things. This is the b value, by the way, and this slope is the a value. And to draw the graph, when x is 0, y is 4. That is the initial value, right? Or you can just go to the y-axis. On the y-axis, the value is 4. That's one point. And the slope is 3, which means what I can do is I can go 1 unit to the right. If I go 1 unit to the right, I will have to I'm going to move this. Okay, so it will be easy to draw. When I go 1 unit to the right, I'll have to climb 3 units up. 1 unit right, 3 units up, because the slope is 3. And that point would be 1, 7, from 0, 4, 1 to the right, 3 up. Okay. And then you join the line. That is the graph of the line y equals 3x plus 4. Okay, so the meaning of the initial value and the slope. Which reminds me one more word for this interpretation of B. Uh, Interpretation of A, we said enough is the slope. The interpretation of B, the initial value that we said, now you see it's the point on the y-axis, right? It's also called y-intercept. INTERCEPT, intercept. Okay, y-intercept. All right. Now let us get into the concept of slope a little bit more. The slope we have been introduced is the rate of change. And what is the formal definition? Rate of change. So how much did the y value change when the x value changed by a certain amount? The change in y divided by change in x is the slope. Okay. So let us take that definition of slope and apply to this triangle ABC, which has these three vertices. I will solve the first one, slope of AB. When you use notations, often you can use like this. Okay. Another symbol for slope is that M, typically. Okay. Earlier we wrote y equals ax plus b, but you will also find this equation in literature, in textbooks and online, any articles if you read. Okay. It's called the the linear equation of a line, and M it is a convention. Okay, M stands for the slope, and here we are talking about slope of the line AB. So this is another like notational convention. You write the M for slope of what? Of the line AB, right? So you write that in the subscript. Okay, so M subscript AB equals AB. I'm going to highlight here these 2 points. Okay, and which one is x1 y1, which one is x2 y2, you choose. Okay, so let's say A is x1 y1 and B is x2 y2. So then according to the formula it will be y2 minus y1. So 6 minus minus 3 over x2 minus x1, negative 6 minus 4. Okay, and when you simplify that, I'm going to continue it here. 6, it will be 6 plus 3, 9, and minus 6 minus 4 will be minus 10. 9 divided by minus 10. Again, generally we write that as minus of negative 9 over 10. Okay. What you should do now, go ahead and find the slopes of BC and AC. Pause the video, do that, and then check your answer with me. Okay. BC will be 0 minus 6 over 8. Minus minus becomes plus. When you get used to, you can do it directly. Okay. So that will be minus 6 over 14, which is minus 3 over 7. And slope of AC will be 0 plus 3 over 8 minus 4, that is 3 over 4. Okay. All right. If anyone was wondering, I didn't explain that. The 6 over 14 we cancel, you divide by 2, that is 3, that is 7, right? 2 times 3 and 2 times 7. So the lowest fraction will be 3 over 7. Okay. The special values of the slope, what we have already covered that in the diagrams. I'm just going to review that here. The three special values: when the slope is 0, horizontal line; finite, oblique line; infinite. Infinite means plus minus. Okay, will be vertical line. Okay. The last one, I will give an example. On top of my head, I don't remember if there is an example that I have written in the notes. So let me write one immediately here. Suppose your points are 4, 3, and 7. No, 4, 7, let's say. Okay. And then your slope. Okay, for such a line, the slope is going to be 7 minus 3 divided by 4 minus 4, right? Which is 4 divided by 0. That divided by 0 is when it becomes undefined. And that's when you know the line is a vertical line. Okay. All right. So the equation of the line that we saw earlier, that ax plus b, which I said, has the interpretation of a and b, where the slope and the y-intercept. So that form of equation of line is called slope-intercept form. And we write it as y equals mx plus c. Sometimes you will find mx plus b also. Okay. Again, as long as we understand, it's fine. The slope is m, and the y-intercept is the value c. Okay. And no harm in once again quickly drawing the diagram, so it's very clear to us, what we are talking about here. So if this is my line, the point on the y-axis is that 0 comma c, that is the y-intercept. And the meaning of slope is, I'm going to zoom in and show you so it will be clear. From this point to this point, and any 2 points on the line, doesn't matter. Okay. If, in proportion, if this was 1 unit, that is m units. That is the meaning of the slope m. Okay. The change in y divided by change in x is m. M divided by 1. If it is 2, then 2m. The ratio is m. Okay. Let us look at a real world problem. In 2011, the total retail revenues generated by SMS and MMS messages in the UK was 2,539 million in Great Britain pounds. Yes. During the next 4 years, the revenues declined on average by 467 million GBP per year. Okay. So that is the situation. Now you find the values of M and B so that that line models the retail revenues in the X years after 2011. Okay. So what is the variable here? The years after 2011. Okay. So that means you should understand for 2011, the value of X is 0. Okay. And then for 2012, the value of X will be 1 and so on. So that's what is meant by X years after 2011. And in this situation, what is the rate of change? Remember the interpretation we talked about. Okay, m is the slope, the rate of change. B is the initial value. At the beginning, what was the value of the function? Okay, think of that and try to figure out which one is M, which one is B. Okay. Now check with me if you thought like this. The total revenue in 2011, that is initial time, right, was this. So that was the initial value of the function. That is the B. And during the next 4 years, the revenues declined by on an average per year. So this word per year should tell you that this is the slope M. Okay. So the values would be written like this. M is, there is a small extra thing I'll talk about in a second, 467, and B is 2539. Okay. The extra thing is we write negative minus 467 because the revenues are declining. You have to be careful about that. Okay. About the slope, you have to be always careful. Is it increasing or is it decreasing? Here it is decreasing, so negative. M is negative 467. Use the model. Okay, so the model is y equals negative 467x plus 2539. Okay. Use the model from part A to estimate the retail revenue generated in the year 2014. And that will be in 2014, value of x will be not here. Okay, for 2011 it is 0. So for 2014 it is 3, right? And therefore your revenue, okay, revenue is y value, which is negative 467 times 3 plus 2539. Okay, and punch that in the calculator. 2539 minus 467 times 3. Okay, 1138. Okay, 1138 million GBP. Okay, we'll look at some more. That was one example. Now we are going to look at some more practice problems in this concept. Okay. By noon, 3 inches of rain had fallen during a storm. Rain continued to fall at the rate of 1/4 quarter inch per hour after that. Okay, after noon, Find a formula for a linear function f that models the amount of rainfall x hours past noon. Okay, please pause the video. You solve it first, write the equation, and then check with me. Okay, so that means at noon here, x is 0. And your equation should be this: 1/4 x plus 3. Right? The rate is 1/4 inch per hour. The initial value at noon, by noon 3 inches had already fallen, right? So the initial value is 3. Y-intercept is 3. Find the amount of rainfall by 2:30 p.m. So from noon to 2:30 p.m. Okay, at 2:30 p.m. value of x is clearly 2.5. Right, from 12 noon, and because we are x is in hours, okay, x hours past noon, we're talking about hours here. So 1 hour is 1 unit. 2:30 will be 2.5 hours. And so the amount of rainfall will be 1/4 times 2.5 plus 3. Okay, so that will be 3.1.25 inches. Okay, look at the next problem. A linear function f has the following ordered pairs listed in the table. Use the table to find the slope and the y-intercept of the graph and give an equation that defines f. Okay. So x and f of x values are given. From that, find the slope, find the y-intercept, and write the equation. Okay. I am pausing and going a little slow because I want you to be doing ahead of me. Okay. The slope will be, take any 2 points. Let's say take the first two. Doesn't matter. And you should verify that. You take any 2 points, it will give you the same slope. That is the beauty of a straight line. Okay. It always has the same slope. Say I took these 2 points. Then y2 minus y1. Y is f of x. The y values are in the second row. So negative 6 plus 10 when you subtract divided by x2, negative 2 plus 3. That is the slope. So that is 4 over 1, 4. The slope is 4. And what is the y-intercept? Y-intercept 0c is here, 0, 2. Now, when you write y-intercept, sometimes you just write c, the value of the y value on the y-axis. Sometimes you write the point 0c. Both are used. Synonymously. Okay, and it's not a big confusion there because we're talking about the y value, and there is a specific point on the table, so it was easy to find the y-intercept here. If it was not given in the table, we would have to do some extra work to find that. Okay, so clearly that means your equation is y equals 4x plus 2. Okay. Next, a moving company charges a flat fee of $40 plus a rate of 50 cents per mile driven. Oh, hopefully, there was something like that today. In today's prices, that would be great. Find the charges a customer must pay for moving to a location 300 miles away. Again, identify what is the value of M, what is the value of C, what is the initial value, what is the rate. Okay, and I'm sure you wrote this. M is 0.5 and your B, I'm using the symbol B this time, okay, is your initial value or the y-intercept. It's $40 flat fee, right? Even if you drive only 5 miles. And so your equation, okay, the charges that you must pay is f of x is mx plus b, so that will be 0.5x plus 40. Now a customer is moving to a location 300 miles away, so that is f of 300, right? X is the number of miles and f of x is the charges. 0.5 times 300 plus 40, that is 150. 0.5 is 50%, half, half of 300, 150 plus 40, we get 190. Okay. A woman purchased a new car with an initial $1,000 down payment and a monthly installment of $350. Formulate the amount she pays X months after the purchase as a linear equation. Okay. How long will it take her to pay off the vehicle in full if the total amount is 19,700? Very interesting question. Okay. First, write the linear function and then we will solve. Okay. I'm going to write directly this time. Okay. This monthly installment is the rate, right? At which she has to pay. That is 350 X. So in X months, she would have paid 350 every month. So in X months, she would have paid 350 times X. Plus initially she put down $5,000. Okay, that's the initial value, the Y intercept. Okay. Now the question is, how long will it take for her to pay in full? The total amount she has to pay is this, which is the Y value. You have to understand that. Okay. The amount that she is paying. X is the independent variable here is the months, number of months. Y is the amount that she is paying. Okay. The total amount at any given month. So substitute out right here. Okay. Substitute Y equals 19,700. What do you get? 19,700 equals 350x plus 5,000. Now you have to solve this equation. Okay. Now, solving linear equation is going to be a idea, that we are going to see more in future also. But some basic rules, based on some basic rules that we know, we can solve here. Whenever you want to solve for an equation, one of the basic rules is you want to isolate that variable. You want to solve for x, right? You isolate it. Isolate means what? Everything else you take it to the other side. So for example, I'm going to move the 5,000 to the other side. So what will that give me? 19,700 minus 5,000. See, when you move the side, you have to follow the rules. Okay, there is plus here. On the other side, it will be minus. Equals 350x. Okay. Actually, what I should do is I should write a little bit above here. Okay. So here we're continuing there. And that gives you 12,700. No, 14,000. 19 minus 5 is 14. 14,700 equals 350x. Isolating the variable, right? Now you need to get rid of the 350. It is multiplied. So you get rid of it by dividing. Divide by 350 on both sides. You cancel that there. On the left side, use your calculator. Okay. One of the zeros you can cancel anyway. I can see mentally actually 2 times will be 70 and 4 times will be 140. Or I don't know if I'm going to get an exact value here. Looks like we might get an exact value also. 22 or something maybe. Okay, let's do it. 14700 divided by 350. 42, not 22, 42. Okay. So 42 equals x. So the question, how long will it take? It will take us 42 months. Okay, that is what, 3.5 years. Okay, in 3.5 years, she will be owning the car, which is great. Okay, let's be happy for her. Okay, good. We're able to finish so many problems in that. Equations of lines and linear models will be our next topic. See you then.